Hello, 6th grade wolves. This is Chapter 5.1, Rates and Unit Rates. In this lesson, we'll solve unit rate problems, including unit pricing and constant speeds. Let's get started. Before we begin, let's identify what rate means. In our last chapter, ratio, we found that we could compare two quantities that had the same units. For example, if we had a ribbon that was 80 centimeters long and a ribbon that was 92 centimeters long, then we could write a ratio that shows 80 to 92. We didn't have to include the units because the units were the same, right? Centimeters. Now, when we're talking about rates, we can use rate to compare two quantities that have different units, such as money and time. So those things we couldn't compare with ratios, now we're going to learn how to compare using rates. For example, let's say Sarah earns $23 for a single hour of work. There are several different ways we could write that. We could write $23 per hour, or we could write $23 over 1 hour, or we could write it as $23 per hour. This example right here is a rate. This is an example of a unit rate. So a unit rate compares a quantity of one unit to a different quantity. So we have two different units going on here, right? We have dollars, and we have hours. And this symbol, whenever you see it, means per. So we would read this as $23 per hour. That's our unit rate. Let's work together to compute a unit rate. Nick fills 24 bottles in 8 minutes. At what rate are the bottles being filled with water? Well, let's see. We have 8 minutes. Let's draw a picture here. We have 8 minutes. And in that 8 minutes, we're filling 24 bottles. So we want to figure out how many bottles are we filling each minute? How many bottles are being filled in this one little segment of time? We'll set this up very similar to our ratio problems. We'll say 8 minutes equals 24 bottles. Now we solve for 1 minute by dividing each side by 8, which gives us 3 bottles. So every minute we're filling 3 bottles. So the rate is 3 bottles per minute. See how that works? Let's complete another similar problem. A photocopy machine can print 405 copies in 9 minutes. What is the rate at which the machine is printing the copies? Once again, we'll start with a picture that represents our entire time frame that we know, 9 minutes. We know that this 9 minutes allows us to make 405 copies. So we want to solve for the number of copies made in a single minute. And we'll do that by writing 9 minutes is equal to 405 copies. Now we solve for 1 minute by dividing each side by 9. 405 divided by 9 is 45. So our rate is 45 copies per minute. Now let's find a unit rate. Let's say a school buys 2.75 acres of land for a new athletic field. What is the cost per acre if the school pays $275,000 for the land? So what we need to calculate here is what is the cost per acre. So we could very simply find that by simply taking $275,000 divided by 2.75, or the cost divided by the area. So let's solve this problem. 275,000 divided by 2.75. The first thing we need to do is rewrite this division sentence as a fraction, just to make our work a little bit easier. So 275,000 divided by 2.75. Now we need to convert our denominator to a whole number. We can't divide by 2.75. So we're going to multiply 2.75 by 100. And whatever we do to the numerator, we must also, our denominator, excuse me, we must also do to the numerator. So let's multiply that by 100 as well, giving us a new fraction, which is 27,500,000 divided by 275. Okay, well, we can see immediately that 275 here divided by 275 here is going to give us 1. And we have our 5 zeros remaining, making our answer $100,000. So our school paid $100,000 per acre for the land for the athletic field. There we go. Now try these two problems on your own. Find the unit rate for the cost of land for the sports center in problem 1. And in problem 2, find the cost per gallon of gasoline. Press pause while you work, and when you come back, we'll start on our next idea. Now let's learn to find and compare unit rates. This table shows the costs of some fruits purchased at a farm stand. Which fruit costs the most per pound? To find out which fruit costs the most per pound, we're going to divide to find the unit cost of each fruit, or in this case, we'd call it the unit rate. So first, let's calculate the cost of mangoes per pound. So we'll divide the cost by the weight. So we bought $2.60 worth of mangoes and purchased 2 pounds. So the cost per pound is $1.30. Pears, we spent $3.50. We purchased 2.5 pounds. That makes the cost $1.40 per pound. So pears cost $1.40 per pound. Oranges, we spent $2.70. We purchased 2.25 pounds, and that gives us a cost of $1.20 per pound for the oranges. Our question was, which fruit costs the most per pound? So let's make a chart comparing our costs. The cost of oranges was $1.20 per pound, which was less than the cost of mangoes, which was $1.30 per pound, which was less than the cost of pears at $1.40 per pound. So pears cost the most per pound. Now try a problem like this on your own. This table shows the costs of some food items that Billy bought from a supermarket. Which type of food costs the most per pound? Follow the exact same steps as we did with the fruit stand problem. First, calculating the cost per pound of each individual food, the potatoes, the carrots, or the onions. And then compare the quantities to determine which one is the most expensive per pound. Press pause while you work. We have one more idea in this chapter when you come back. To close out chapter 5.1, we're going to talk about speed. Speed is a very specific kind of rate. Speed is the rate that compares distance traveled to the time taken to travel that distance. We write it as S equals D for distance divided by T for time. This is a rate that you use all the time without even really thinking about it. For example, let's say Gavin drove from town A to town B, and in 1 hour, he drove 50 miles. So we can calculate that since he went 50 miles in 1 hour, he went 50 miles per hour. That would be his speed. Now let's explore two different methods for calculating speed when given information such as distance and time. A car travels 120 miles in 2 hours. Find the speed of the car. In method 1, we'll use a bar model. We'll say we have 2 hours, which we'll represent as a bar divided into 2 equal parts. We know that that bar represents 120 miles. So how far do we travel in one of these units? 2 hours equals 120 miles. So 1 hour would equal 60 miles, giving us a rate of 60 miles per hour. Miles per hour is often abbreviated as mph. So you could also write 60 mph and be correct in this case. Now let's look at method 2. In method 2, we're going to use the formula that I introduced before to calculate speed. Remember, speed is distance divided by time. So we're going to substitute in the information we know to solve for what we don't know. Speed equals distance, 120 miles, over time, 2 hours, giving us 120 divided by 2, or 60 miles per hour, or 60 mph. Two different ways to get the exact same answer. Use whichever one works best for you. And let's close up this introductory portion of Chapter 5 with 2 final practice problems. In number 4, please find the speed of the truck if the truck traveled 280 kilometers in 4 hours. In number 5, if the car travels 1/4 of a kilometer in 1/2 of a minute, find the speed of the car in kilometers per minute. Thanks for your hard work today. I'll see you tomorrow for more practice with unit rates. Have a great night.